recording one more time and then share the screen. Okay, so I'm muting all, but giving you that opportunity
Okay.
that you can, yes, you can unmute yourself anytime. So
Okay.
yeah, and let me make it a full view. So okay, so yesterday, so before going our example, we just give a small reminder that we discussed that there are three types of steam. One is wet steam, dry steam, and superheated steam. Okay, there are three types of steam we discussed, and we also discussed the total heat of a system equation or the enthalpy equation. H, where H was the enthalpy, HF was the sensible heat, and HFG was the latent heat we discussed in the last class. Okay, so also we also discussed one more term, that is X, which is dryness fraction and totally related with the wet steam. Okay, totally related with the wet steam. It's not about dry steam, because X represents, suppose X value is X equals to 0.9. That means suppose the value of X is 0.9. So which means that 90% of your water has converted to steam. So 10% is left. So for dry steam, the value of X equals to 1. Remember, for dry steam, the value of X equals to 1. What does it mean? It means that 1 means 100%. 100%. So that means that your total amount of water has converted into steam. So that is dry saturated steam. There is no water element left in. So that was dry steam. And finally, we got the superheated steam, where we will also calculate the superheated temperature and the boiling temperature difference. And finally, we get this equation where Cp is the specific heat. We also represent Cp as S also. So there is no difference of S, Cp, Cs. There's nothing. Every one is a symbol, but the meaning is specific heat of water, which will be given. Okay, specific heat of water or specific heat of steam. Okay, so which will be given. No problem. So this was just a remind. Uh, let me you can give your role in the chat box. Everyone give your role in the chat box. So okay, in the last class we discussed this, but still today we also discussed this today. Okay, a little bit, that you see that it was given here that at a p equals to 10 bar, that means the pressure value is given. Okay, p equals to 10 bar, and the dryness fraction is X equals to 0.9. So the dryness fraction X equals to 0.9. Who is Muska Biare? Muska Biare, who are you?
Is Ibrahim.
Okay, okay, Ibrahim. Everyone is coming with a very weird name. Okay, so P equals to 10 bar. The pressure value is given, the dryness fraction X equals to 0.9, and it was told that what will be the value of H, the total heat of a system. Okay, as there is nothing written here that what type of steam it is, but we can definitely guess from this, because we know that there are three types of steam. One is wet steam, one is dry steam, another one is superheated steam. But you can say that there is nothing written here, but still a clue is given, that is dryness fraction, because we already know that the dryness fraction only deals with wet steam. So that's why this is the wet steam, and we know that the equation of the enthalpy or total heat for wet steam, H equals to HF, H equals to HF plus X into HFG plus X into HFG. Sorry for this. Okay, so from here, the value of X is given, which is 0.9, and we have to get the value of HF and HFG, the sensible heat and the latent heat. I told you that we will find these two values from the steam table. Okay, from the steam table we will find that value. Okay, let's go to the steam table. Let me clear the drawing. You see that this is the steam table. This is the steam table where the first column is the pressure, the P equals to P bar, that is pressure column. Okay, the first column is the pressure column where different value of pressure is given. Different value of pressure is given. But you see that the value 1, 1.5, 2, 2.5, our pressure is 10. You see that our pressure is 10. So we mark this row, we mark this row 10. And there are several columns here. One is HF, this one is the HF, the sensible heat column, and I told that R is HFG. R is HFG. Okay, so this is the latent heat column. So we will take the value of latent heat and sensible heat from these two columns. So if I go from 10, the same row will give me the value. So 763 something and 2015 something. So we'll take this value from this steam table and go back to our equation. So let's go back to the equation. You can see that it is told that at P equals to 10 bar, this value to R, and it is getting from steam table. Okay, so we just put this two value. And finally we get the total heat of the system of this wet steam at P equals to 10 bar. So this was a very basic example. So we'll move forward to the next one and see something more tougher, or not more tougher, but a little bit different. Okay. The interesting thing is that this is the steam table. This steam table. Okay, the steam table has two characteristics. What? You see that the sensible heat, the value, these are the values. The latent heat value, these two value, or these values are calculated for 1 kg. I have already told that we will take 1 kg as a standard, because these are the experimented value taken from the laboratory. So we need to fix a particular amount, that for the uniformity. So that's why they have taken 1 kg. So we have to remember that whatever the value we are taking from the steam table, the value are for 1 kg. And the next is we told that the sensible heat and latent heat, the sensible heat starts from the 0 degree Celsius. Okay, starts from the 0 degree Celsius water. So whatever the sensible heat that is taken, or that is given in this diagram, is from 0 degree Celsius. If you give heat 0 degree Celsius, that is written here in this steam table. So remember these two. One is 1 kg, the mass, and another one is the sensible heat. It starts from the 0 degree Celsius. So these are the two assumptions we need to take to move forward. Okay. Let's go to the example and finally discuss that. What is, you see that calculate the enthalpy, that means the total heat of the system. Same thing, just H of 1 kg of steam at a pressure of 8 bar and a dryness fraction of 0.8. So you see that there is no clue of what type of steam it is, but whereas the dryness fraction is given, as the dryness fraction is given, so we have to understand that this is wet steam. So yeah, this is the equation for wet steam, HF plus X into HFG, and the value of X is given here already for 0.8, and we need to find out the HF and HFG. From where we will find out? We will find out from steam table. To go steam table, we need the pressure value. Here the pressure value is given 8 bar. Here the pressure value is given 8 bar. Okay, the pressure value is given 8 bar. So we'll go to the steam table, and let's see what is the value of 8 bar. Okay, let's check what is 8 bar, the value. This is the 8 bar, if you can see from my drawing. So if I go to the same row, this 721 and finally 2048. So these are the two values for the 8 bar. So we'll take this two value from this table and finally go to the equation one more time. Okay, so we just need the value of pressure. So if we get the value of pressure, we can easily get the value. So you see that here is written that at 8 bar from steam table, these two value, this is 721 and 2048 from steam table we get. So finally we put this value here and we get the total heat of 1 kg wet steam. Okay, so this is quite same, exact same of the last example we discussed. So there is nothing new. So the first line is done. We have the second line that you can see that how much heat would be required, how much amount of heat would be required to raise 2 kg of steam from water to 20 degrees Celsius. Okay, so how much heat would be required, and to raise 2 kg of steam, always remember this type of mathematics. You always calculate for 1 kg. You always calculate for 1 kg of steam. When you get the value for 1 kg, you just multiply with 2, 3, 10, 50, whatever the value. But always try to calculate, not try to calculate, you have to calculate for 1 kg. Because why this restriction? Because we have to use the value from steam table. And the steam table, I already told you that in the steam table, the mass has been taken as fixed, because these are the laboratory experimental values, and for laboratory experiment you have to have a fixed amount of weight. When you don't have a fixed amount of mass, you cannot get the exact uniformity. So they have taken 1 kg and calculated the value for different pressure value and make this uniform steam table. So for that reason we have to calculate for 1 kg, and then we just multiply with 2, 3, 4, stain, whatever the value. Okay, so that is one part. Done that 2 kg. How we'll calculate 2 kg? We will not calculate for 2 kg. We'll calculate for 1 kg same, but multiply with 2 kg later. And one more thing is that given is 20 degrees Celsius. Steam from water is 20 degrees Celsius. Okay, so you see that I discussed that in the sensible heat, this is started from 0 degrees Celsius. Okay, this is from 0 degrees Celsius, but now we are told to calculate from 20 degrees Celsius. Now we are told to calculate from 20 degrees Celsius. But if we calculate from 20 degrees Celsius, there is no direct rule. Okay, my student, there is no direct rule, because whatever the value we have already find out, this is from 0 degrees Celsius, but we are told to calculate from 20 degrees Celsius. So the value we get 2359. Let me clear all drawing, then we'll discuss. Okay, So this is 0 degrees Celsius. Now we are told to find out from 20 degrees Celsius. So understand this. This will be clear. So whatever the value we have find out 2359. Okay. So this is from 0 degrees Celsius. But we are told to find out from 20 degrees Celsius. So if we multiply this 2359, this is for 1 kg. If we multiply with 2 kg with 2, this amount of heat will be extra. We will calculate. Okay, this will be extra taken. So we have to subtract this extra value because we are not told to find out from 0 degrees Celsius. We are told to find out from 20 degrees Celsius. So we have whatever the you know value we will calculate, it will be extra. Suppose you will run from 0 to 100 meter, from 0 to 100 meter. So you have you have run, and the minute the amount of time you require was suppose 20 seconds. So this is the duration for to run from 0 to 100 meter, 20 seconds. But now it is told that you have to calculate the time you took to run from 20 to 100 meter. So if you take the exact amount of time 20, it will be wrong because that was from 0. So what you will do, you will not run one more time. Okay, so what will do, you will run 0 to 20. You will run 0 to 20, and now you just subtract from total from 0 to 20. So to run from 0 to 20, you require suppose 5 seconds. Suppose 5 seconds. So to now you got 5 seconds from 0 to 20, and total 0 to 100, it is 20 seconds. So if you just subtract from 20 to 5, you will get the value from 20 to 100 meter. So this is the exactly same case we will do because we have to calculate from 20. So what we'll do, we have already calculated from 0 to the boiling point, the total sensible heat. Now we will calculate from 0 to 20 and subtract these portion from the total heat. So from 0 to 20, so we already discussed the equation was 4.2 into T kilojoule. If you remember, 4.2 into T. T is the temperature difference. So for 20 degrees Celsius, the amount of heat already available in the water, that is 4.2 into T. Here 4.2 and T, the amount of is 0 to 20 is 20. So that means this 84 kilojoule amount of heat, that is extra. So we have to subtract this value from this total value. Then we will get for 1 kg, and then after that we will multiply that value with 2. That will give us our answer. So let's go to the next. So you see that the actual amount of heat that I told, that this is from 0 to 100, this is from 0 to 20. So when we subtract, the result we will get from 20 to 100. 20 to 100. So that was the required. But interestingly, this is for 1 kg. My students, mark my words. This is for 1 kg. We are told to find out for 2 kg. So what we will do, we will just multiply with that 2, and finally we'll get our desired result for 2 kg of steam, and also from 20 degrees Celsius. So I think that you got it. I described the example, that is the exact similar example, same as the case. So I think you understood. And so this is a little bit different from the previous example. We need to just consider. Let's discuss the third one. If you this will give you much more close, much more better understanding for this kind of example. So similarly, almost same, you say that determine the quantity of heat. If you check that the total heat of a system or enthalpy or the quantity of heat, everything is same. The words are same, exact same. There is no change of word. Okay, so everything, the meaning of three words are exact same. That means total heat of a system. So the equation would be same exactly. So let me start the determine the quantity of heat required to produce 10 kg of steam. 10 kg. So you are told to find out for 10 kg. So what we'll do? Similar process we'll calculate for 1 kg, and finally we'll just multiply with 10 kg. So that will be our strategy from the very beginning. And also a steam at a pressure of 6 bar. So the pressure of that steam also given 6 bar, which will help us to find out the value of sensible heat and latent heat from steam table. Okay, and also from a temperature of 25 degrees Celsius. My student, just the previous example I discussed, 20 degrees Celsius. Now here that is 25 degrees Celsius. So we cannot calculate 25 degrees Celsius to 100. So what we will need, we will calculate from 0 to 100, then we will calculate 0 to 25, and finally subtract, we will get 25 to 100. So that will be our indirect approach. Will when you do not get the direct approach, you have to follow the indirect approach. So that will be our indirect approach that we will apply from 25 degree Celsius. Okay, so under these following conditions, we need to find out the amount of heat that is required for three steam. One is wet steam with dryness fraction, because we all know that the wet steam we need the value of you know we need to find out the value of dryness fraction. That's why it is given the dryness fraction for wet steam. In the dry saturated steam, it is not required. So, and finally the superheated steam, we require this 250 degrees Celsius is the superheated temperature, and also the specific heat is given, 2.3 kilojoule per kg per Kelvin. Okay, so we'll go one by one. First wet steam, then dry steam, and finally the superheated steam. So remember one thing, that in every steam you have to subtract from 0 to 25 degrees Celsius heat. So at the very beginning, what they have done, they have find out the what is the value of from 25 degrees Celsius. So this 105 kilojoule they have find out using the equation 4.2 into T. So this 105 kilojoule heat will be subtracted all three steams, all from wet steam also, from dry steam also, and also for the superheated steam. So they have at the very beginning, before starting the example, they have find out the amount of heat that would be subtracted. So now we will calculate from wet steam. Okay, the wet steam, and the thing is given here already, x equals to 0.9, and if you remember the steam pressure is given 6. So let's go to the steam table and find out what is the value of 6. You see that here the 6 is given here. So the 6 is 670 and 2086. So that is the value from steam table. Okay, you have to just use the steam table like this way. So if you see that this is the 670 and 2086. So if you replace the value with x, you will get the value for 1 kg of the wet steam. And my student, this is 1 kg from 0 degree Celsius. Okay, but we have been told to find out from 25 degrees Celsius. So what we will do, we will subtract from this value to 105. We already find out the value. So this is for 1 kg. And remember, we have find out for 1 kg, but we need to find out for 10 kg of steam. So that's why we'll just multiply with the 10 of this value, and we finally we get this, that for the 10 kg of steam. Okay, so this is the way of procedure for the wet steam. So we will follow the same procedure for the other steam also. So let's go back to the second, the dry saturated steam. We know that the dry saturated steam, the HF plus HFG, this is the equation. This is if you just sum those two value from the you know if you just sum the two value, we already find out from the steam table, you will get this total value. So this is for 1 kg, but it is from 0 degrees Celsius. So that's why we have to subtract from 105, we'll get from 25 degrees Celsius, and finally this is for 1 kg, so we need to find out for 10 kg. So that's why we will just multiply with 10, and finally we will get the value for dry saturated steam. And last is the specific, sorry, the superheated steam, where the T50 to 150 degrees Celsius superheated temperature is given, and also the specific heat is given. Okay, so we will apply these two value. So if you remember properly, this is the superheated steam equation, where T super is given, Cp, the specific heat, is also given, and these two value will get from the we already got from the steam table. But sir, where we will get the TVE, the boiling temperature? Okay, so you will get this boiling temperature also from steam table. You see that at P equals to 6 bar, the boiling temperature is 158.9 from steam table. So it is written there that you can also get the boiling temperature from the steam table. Where? Let me show you. Let me show you that where is 6 degrees 6, this is 6. So the next column is basically the boiling temperature. You see that T degrees Celsius, so this is the boiling temperature column. So if you need the boiling temperature, you can definitely get this value from this steam table. So we have the pressure value 6. So for 6, the steam table gives us that the boiling temperature is 158.8. So one interesting thing I need to say that we always tell that the boiling temperature of water is 100 degrees Celsius. Okay, so that is not the right that means that is not the right information, or not the complete information. We need to say that the boiling temperature of water is 100 degrees Celsius in standard pressure, or one atmospheric pressure, or 1 bar. Okay, so because if we change the pressure value, the boiling temperature also changes. You see that at 6 bar, the boiling temperature 158, so the water will not start to boil before 158. So if you see that the 1 bar here, you will check that the value is 99.60, which is exactly or close to 100. So that is not exact 100 degrees Celsius, but almost 100 degrees Celsius, 99.60. So always remember that the boiling temperature of water is 100 degrees Celsius, that is true, but at 1 bar pressure, or the 1 atmospheric 1 atm pressure. Okay, so that's how we get this value from here on. Now we get back to the equation one more time. So finally, yeah, if you see that, sir, this value we already get from the steam table. This is given here. The superheated temperature 250 is also given here. The TB also we find out from the steam table. So if we get all the value, we get this value. But remember, this value is from 0 degrees Celsius. So we need to find out from 25 degrees Celsius. That's why we subtract 105. We get this value for a 1 kg. We need to find out for 10 kg. If you just multiply with the 10, we'll get the finally the value for 10. So these are the process, to find out both for wet steam, dry steam, and superheated steam. So that was the today's 3 example I solved. But still I will ask you that I will unmute. I will unmute my students if they have any questions. Everyone is unmuted. You can unmute yourself, and you can share your thoughts or share your questions. Anything, my dear students? You can talk. Everyone is unmuted.
Yes, sir.
Yes, sir.
You can talk and tell me that if anything is needs
Sir,
to
it's
be.
easy,
No,
but
no, sir.
it's enjoying.
Yes,
It's not
sir.
hard. It's not difficult.
Okay, nice. Hamza said it's very easy. Okay, nice. If it is easy, then absolutely
That's good.
easy. So anything I need to discuss one more time, my students,
No, sir.
other students?
No, sir. Thank you very much.
No, sir.
So you are telling me to go. Sorry, go. We have got it. So this was for today. So probably I have already uploaded this lecture.
Inshallah.
I have already uploaded this lecture in the last class. So you just practice by yourself.
Yeah, okay.
Yeah, I have uploaded.
Yeah,
You just practice by yourself, and also take preparation and study. So should I end here?
Yes,
My
sir.
Yes, sir.
Yeah, sir. Thank you.
Yes, try to attend. Today I saw some of the students, they have also joined. So two is missing. One is Hassan. No, Hassan is here.
Yes.
Hassan is here. So missing
Yasin.
student Yasin, and Mahmoud.
Ashik.
Yeah.
Ashik is always missing, so I don't consider him as missing.
Yeah.
So he's always missing. So
Only
basically, Mahmoud and Yasin. So
Yasin,
he
yes.
said that Mahmoud is sick, and probably Yasin will join. Yasin used to join. So I will tell the professor. Where is professor? His name is
Professor Musab
Musab Yari.
Yeah, Musab Yari.
So Musab, you try to join. Okay, and that's it for today. That's it for today. Everyone.
Okay, sir.
Okay, sir.
Thank you very much.